no issue. Suppose you must have seen in your colleges as well as in your cities, you must have seen Tata Nexon, right? You must have also seen Windsor, MG Windsor. And nowadays you must have also seen Tata Curve. And sometimes you might have seen a small vehicle, Tata Tiago. So if my DC charger is 60 kW, and if I want to give 60 kW to all these 3 or 4 brands of cars, will they take 60 kW or they will take on what basis? Any idea? Please, no problem. Even if it is wrong, just communicate. No issue. Talk.
It may be depending on onboard battery, sir. Generally, if the battery is 60 volt, actually universally accepted voltage of the battery is 60 volt. So for all the vehicles, a single charger may be adapted.
Yeah. Thank you, sir. Thank you, Subrahmanyam garu. Sir, normally what happens is, like I mentioned previously, Dr. Subrahmanyam garu is correct when he says 60 volts is the usual standard. Usually for scooters, three-wheelers, normally they have standards as 48 volts and or 60 volts. So most of the three-wheelers as well as most of the two-wheelers are usually 48 volts or 60 volts. So the main limiting thing there is the C rate. C rate means we call it as charging rate. C rate means the rate at which the batteries can be charged. And discharge rate is also defined as C rate. C rate means charging rate. Or 2. The inverse of C rate is the speed at which the power can be taken by the battery. If I have a battery which has a C rate of 0.2, it means that the maximum speed it can take is 0.2, means the battery can be charged in 5 hours, 1 divided by 0.2. Whereas if I say that my car can take at 3C, means in 1 divided by 3, within 33 minutes, within 1/3 of an hour, within 20 minutes, the car can be charged, provided the charger is able to provide the required quantum of energy. We come to the next thing. What are the different types of EV charging stations? So what are the different types? There are mainly 3 types. EV public charging station. EV public charging station is similar to your fuel station. Petrol and diesel and natural gas or LPG gas or nitrogen gas fuel filling stations, wherein public can come any time of the day and fill their car, scooter or auto, any vehicle for that matter. That is called as EV public charging station, or in abbreviated form, EVPCS. The next type is captive EV charging station. What do you mean by captive EV charging stations? For example, fleet owners, taxi fleets. Blue was a taxi fleet in Delhi and Bangalore. Means all the cars were based on electric vehicles. So what they will have is they will have a combined charging facility wherein their cars or autos can be charged. Government departments, for example, those who are in different municipalities of the places like in Rajahmundry, Kakinada and different municipalities of Andhra Pradesh, they have their own electrical fleet. So they also have their captive EV charging stations. The next category is private EV charging stations, which are privately owned, like the madam in just a few minutes back, she mentioned that she has a pure electric vehicle. So she has her own socket, her own charger to fill the battery of her electric vehicle. Then again, EV public charging stations are needed in key places, especially highways, public places. Especially those who are traveling from Vijayawada to Visakhapatnam, Delhi to Jaipur, Delhi to Lucknow, Kanpur, Bangalore to Tirupati, Chennai to Tirupati, Chennai to Bangalore. The different highways between cities. Nowadays, you find lots of charging stations. Even you have electrical buses, especially if you see in Andhra, Telangana, Tamil Nadu, as well as northern part of India, you see a brand by the name NewGo. So for these vehicles, the buses, there are public charging facilities. Then there are EV public charging hubs are needed where all EV customers have facility to charge them. For example, near to Hyderabad International Airport, there is a charging hub which can charge approximately 90 vehicles at a time. So as per the demand, the services are also coming up. What are the typical EV public charger specifications? These are the specifications. These are changing. By the way, the public charge. So each brand.
This meeting is being recorded.
This meeting is being transcribed and summarized.
Which defines the amount of voltage and current it can take. The first is the fast charging type, which is called as combined charging system. In India, it is called as CCS2. The output voltage from such chargers is between 200 to 750 or even higher. Some of the vehicle architecture is around 800 volts also. So if 800 volts is required by the vehicle, the charger will provide that much amount of voltage. Number of connectors means it's like your petrol fuel dispensing unit. We call it as guns, charging guns or connector guns. So in a CCS2 DC charger, usually they have 2 charging guns. Which vehicles it can charge? It can charge cars, buses, and trucks. Then comes, usually these are deployed in highways, or these are deployed by fleet operators, or these are deployed in, let's say, transport authorities like APSRTC, Telangana RTC, or KSRTC, like that, state road transport corporations. Then you have fast type 2, we have seen previously, wherein everything is the same here. The minimum is 22 kW and the output voltage is the same as our normal 3-phase output, 380 to 415 volts. And the number of guns are 1 gun or 1 connector gun, and it can be used for charging a car. Even buses can also be charged with type 2 chargers. In place of 22 kW, such chargers can be as big as 80 kW. Then you have moderate, which are installed by car owners inside homes, 7 kW or 11 kW. And typically they have only 1 gun and they are only used for cars. And then you have slow and moderate. Bharat DC 001 and Bharat DC 001 are obsolete because nowadays no vehicles are being manufactured with GB by T connectors. Bharat AC refers to universal charger, wherein only socket is provided by the charging station provider, wherein the customer can bring their own charger and they can use the socket that is provided by the service provider. In this, the output voltage is again 230 volts. And the number of connectors, there are 3 sockets. Connector guns, it is not connector guns. There is a typographical error here. 3 connector sockets of 3.3 kW maximum. And it can be used by any vehicle because they are bringing their own charger. It can be a 2-wheeler, it can be a 3-wheeler, it can be a 4-wheeler. If they bring their own charger, they can charge in this particular bus AC 001. But the only downside of it is a slow charger. If you are coming out of your home to a different place, you are short of time. So that can be a major disadvantage of Bharat AC 01. Then again, we come to EV charger management system, wherein we have all this. When we go to the back slide, we are talking about EV public chargers, means EV PCS. We were talking about EV PCS, EV public charging stations. So for a EV public charging station, they can be remotely operated. Most of the places you might have seen a charger inside a petrol filling station or inside a restaurant or a hotel, which are unmanned. So when you say unmanned, how do we operate the unmanned chargers? So it is operated by a system called as EV charger management system, wherein an app is developed. The EV supply equipment. So we will come from left to right. Okay. There is an app on your mobile phone, smartphone, through which you can start or stop a charging session. From the mobile app, you will give a command through the CMS to the EV supply equipment after you put your gun or after you install your charger to start the charging mechanism. So when through your app remotely, now some people may be attending their conference from Delhi or some other place in Bangalore or Calcutta or Mumbai. They can, sitting from their chairs, they can operate a charger, and they can operate a charger to facilitate charging of a vehicle. We will do this exercise when we go to the last slide. So what are the main challenges? So these are the challenges which I have seen in the last 2.5 years of my experience of operating EV charging stations, or being in the business of EV charging stations, or being in the business of developing electric vehicles. So the first and foremost challenge is installation of a charger in a residential society and apartment. So what happens is, many of you may be working on a job in a particular engineering college or in university, and which may be not your own town. You may be temporarily based in a particular apartment and have taken the apartment on a lease or a rent. So in such a place, if you want to install a charger, always there is an issue with resident welfare society or the facility management company inside the residential complex. If you are staying inside an individual house, it's not a challenge because you can install your charger wherever you want to. But when you are inside a residential society and an apartment, it can be challenging. 1 second. Installation of charger inside a residential society and apartment can be quite challenging. One thing which you might have noticed is your meter box will be at one location and your parking slot will be about 100 to 200 meters away from a particular location. So routing of the routing of the power from the meter to your parking slot can also be challenging. The second challenge we normally see is improper earthing. So most of the places, most of the apartments, at the time of building the apartment, the earths are maintained. After the builder hands over the apartment flats to the individual owners or the tenants there, the earthing, we don't know how it can be. So improper earthing can be a big challenge if you are having chargers which need to charge your car, especially a 7 kW charger or 11 kW type 2 charger. Proper earthing has to be there to ensure that there are no electrical accidents while you are charging your vehicle. So improper earthing, it's not in your control. So you have to ensure that whenever you are having a charger installed, the voltage between earth and neutral should not be more than 2 volts. When it is greater than 2 volts, it means that the earthing is not proper. You need to take some action to ensure that earthing is rectified. Knowledge on usage of public chargers varies with age of customers. So people who are used to using smartphones, especially who are Gen Z, let's say below 30 years, 35 years, we find them, they are very what you call knowledgeable when it comes to using the smartphones for downloading different apps and using those apps for charging the cars or vehicles. So we see that problem especially in B1 and B2 towns. Then the other challenge is serviceability of EV chargers in B1 and B2 towns. This is very predominant, especially if you are not based out of the 6 metros or 8 metros of this country. It is very difficult to get the chargers serviced. Because, for example, we are in a place called Rajahmundry, which is around 500 kilometers from Hyderabad and around 150 kilometers from Vijayawada and 200 kilometers from Visakhapatnam. So if there is any service issue with any of the charger, public charging stations charger, it takes around 2 days for a person to come from Hyderabad. Means if he wants to come, he has to devote 2 days. For example, 1.5 days of transport and half a day for fixing the error. So that is a main issue, especially in B1 and B2 town. No serviceability of chargers, especially portable chargers. If you are owning a two-wheeler, we should pray that there should not be any problem with the charger. Once there is any problem with the charger, there is no serviceability with the portable chargers. It is like use and throw. But we are trying to see if we can do service of that particular chargers in our office, in RenEV projects. But again, that is very challenging because most of these chargers have a rectifier unit and then they have a control unit. If anything happens inside the rectifier unit in the portable charger, nobody knows what is the circuit diagram. So because of no circuit diagram or because of confidentiality of the charger manufacturers, we know which part or which components is damaged or which needs to be replaced or rectified. Then again, financial stress for replacement of portable chargers. Especially this we have seen for autos, especially for three-wheeler autos. A portable charger costs anything between 24 to 25,000. So for a auto driver to buy a charger of 24 to 25,000, they normally are not capable because they have they run by the day. Whatever they earn in the day, they usually spend in the day. So if there is a damage of portable charger, it is a big stress, financial stress for auto drivers. Voltage fluctuations, especially if you are in rural areas or semi-urban areas, the voltage fluctuations in the network is very high, especially if you are on an agriculture feeder. When the agriculture load is not there in the feeder, there can be huge spike in voltages. That also damages the charger, or the charger does not function at all. Then again, the other challenge is fast charger works as a slow charger after 90% of the state of charge. No matter how much big DC charger or a DC fast charger you install, after 90% of your battery is full, it works as a slow charger. So then again, if you are operating a EV public charging station, if the car owner or the vehicle owner does not have civic sense or does not have common sense, it becomes like a big parking issue wherein a person is waiting with 10% charge and this person is almost full, but he doesn't vacate. So that becomes like a bit of nuisance, especially for EV public charging station operators. We call them as charge point operators. Then misuse of EV charging station as a parking area. This happens especially in public charging facility, like a railway station. There is a dedicated slot for EV cars or EV scooters, but because of emergency situation at times to catch a train or something like that, people park there and go. But then again, it becomes a huge challenge. Misuse of EV charging station operations. Normally what happens is you take permit for a EV charging station, but you don't provide, let's say we installed one charging station inside a medical complex, inside a medical college in Rajahmundry, one of the huge medical colleges, GSL Medical College. We could not operate the charging station because we could not control the parking space. And then the same space was being used for unloading materials and those sort of things, because of which it becomes a huge inconvenience if you are remotely operating a EV public charging stations. The last one, which is a real pain point, if any one of you is owning an electric car, especially in your phone, there will be about 18 to 20 apps. So there is no single app from which you can operate a charging station. For example, in Rajahmundry, we have 4 or 5 public charging stations. Each of the public charging station operates on a different app. So if someone is coming from Visakhapatnam, Vijayawada or Hyderabad or some other place, so he has to ensure that he has that many number of apps on his phone to run his car or whatever it is. Any questions until this point before I move to a small exercise? Any questions, sir? Any questions?
Sir, we have a question in the chat box asked by Dr. Roja.
How to open the chat box?
So let me read out the question for you, sir.
Sir, I'm not familiar with it.
Yeah. I have heard an 800 volt EV charge slower on a 150 kilowatt charger than a 400 volt EV. Is this true? Let me repeat it, sir. I have heard.
Please.
I have heard an 800 volt EV charger slower on a 150 kilowatt charger than a 400 volt EV. Is this true?
I could not understand it, but I'll try to answer it. Okay.
So otherwise,
So,
sir, on the right, there is a message symbol. Usually the text message we have a symbol, right, sir? On the bottom right of your screen.
participants panel.
After participant panel, beside participant panel, there is one message symbol, right?
Chat.
Yeah,
Okay, chat is there.
Yeah, you open that.
I have seen that one.
Yeah.
I have heard an 800 volt EV charger slower on a 150 kW charger than on a 400 volt EV. Is this true? Dr. Korean, sir, actually EV charger, a DC fast charger works on the architecture, battery architecture of a car. It can be 800 volts or it can be 400 volts or as per the design of vehicle manufacturer. Irrespective of the voltage architecture, the DC charger has the capability to provide the voltage or current as per the needs of the vehicle. So that's why there is a control mechanism, control and communication mechanism between the DC fast charger and vehicle. If the DC fast charger, whether it is 150 kW or 180 kW or 240 kW or 60 kW, irrespective of its size, based on the communication it receives from the vehicle, if the charger is capable to provide that much amount of voltage and current, it will provide. It does not depend on the vehicle voltage architecture. It depends on the charger capability to provide that voltage and current or not.
Thank you, sir. Thank you. Thank you. Got clear.
Any other question we have? Okay. Since there are no more questions, sir, can I go to the exercise, sir? Dr. Subrahmanyam garu?
Yes, sir.
Okay. See, we are going to have a very small exercise here, wherein I'm owning a charging station in Rajahmundry. So what I would suggest is the exercise. The first exercise is I want you guys, maybe whoever is technically savvy, to download the two apps. One app is by the name Bolt.earth. Other app is by the name Plug Easy. Can you put the charger? My scooter is ready. Can you put the gun? And Bharat AC also, socket one. So when we talk about exercise, the first point is charger management system. What is a charger management system? Charger management system is an app which will facilitate you to switch on remotely the charger for charging your electrical vehicle. So I have given you two chargers in my corporate office. One charger is based on Bolt Earth, which is a fast charger for two-wheeler. Other charger is a Bharat AC charger, which can charge any type of vehicle. So anybody can volunteer, 2 people or 3 people can volunteer to download, or anybody can download and tell me when they are ready. Please download bolt.earth, register with your name, mobile number, email, enter a referral code. You don't need to pay any money there. You will get a 50 rupees wallet free in your wallet, Bolt wallet. Register your vehicle as Ola S1. I have kept my vehicle there, so register it as Ola S1. The second charger is the Bharat AC charger. Has anybody been able to download? Has anybody downloaded the apps?
Downloading, sir.
Okay.
Sir, it is asking a referral code.
A referral code, please put, have given that in the presentation, no, sir. PULA 7367.
Okay.
Okay. So as you can see, this is our charger. Okay, and we are going to start remotely if anybody of you is ready. And this is my vehicle. Okay, this is Bolt charger. Once you start charging, once you start charging, this will slide. If anybody has been able to download and start the charger, we will be able to see the transition.
Sir, it's asking registration number, sir.
Registration of XXX. Is this charger visible to you all?
Yes, sir. Yes, sir.
Okay, I will show you using my smartphone so that you are familiar with it. See, I have downloaded this Bolt. Oh, sorry, I'm showing Bolt app. This will be Bolt. Okay, the one with like a thunder. Open it. Okay. On this vehicle symbol, just tap. Or you go here. Book a charger. Has anybody been able to do it?
Yes, sir. I am there till there. I have to click on book a charger, sir.
Bus, you have to just book a charger. Type 6. Use type 6, please. Has anybody been successful, or we skip this exercise? It's very simple. So that's why I thought probably we can do it, someone.
For me, it's showing only buy charges, sir. Booking not
No.
showing, sir.
Booking. You are in which place, sir?
Visakhapatnam.
You can just go to that booking. 1 minute. I'll guide you. 1 minute. Where are you, sir? Open the app now.
Yes, sir.
Once you open, okay, you come to Rajahmundry. You will see one green
Rajahmundry.
in the vehicle, in the maps.
Yes,
You will
sir,
see
sir.
one.
Rajamahendravaram showing, sir. Yes, sir.
Near to Godavari river, you will find one green vehicle. You tap on that vehicle, you will get my charging station. Or your good name, sir?
Sitaramaswamy.
Sitaramaswamy, on the bottom of your smartphone, you will see one thunder in green color, scanner in
Yes, sir.
green, and then
Yes,
right
sir.
side you will see a person, right?
Yes, sir. Yes, sir.
You just click on the scanner.
Yes, sir.
After you press on the scanner, you will find here enter charger ID manually. You
Yes,
just
sir.
click
Yes,
that,
sir. Yes, sir.
click that,
Yes, sir.
and after that you just type this L1, L capital, the one in the presentation.
Yes, sir. Okay, sir.
L1
Yes, sir.
DC
DC 0028.
dash 1.
Yes, sir.
It then
Connecting.
starts, sir. It will come.
Yes, sir. Now book charger came, sir.
Then do it. What? Book cheyandi. Just
Yes,
book.
sir.
50 minutes you charge, you take and book. Any problem?
No, sir. It's asking email ID. So
Just give your email out.
now it's asking pay 3 rupees and charge.
Pay?
3 rupees and charge.
Okay, no problem. Pay 3 rupees.
Yes.
No, reduce the charging time. 30 minutes.
1 minute.
Slide cheyadame. You just need to slide.
Okay, sir. Okay, sir. Okay, sir. Yes, sir.
Now it is coming.
Yes, sir. I have clicked on start charging.
So see, it has started charging.
Yes, sir.
You can see
Wait for
everyone.
on. Yes, sir. Yes.
You can see on my scooter also here.
Okay, sir.
So you can see here charging 46%.
Yes, sir.
Yeah.
Thank you, sir.
Okay. So that's what it is. So it takes, because it is for the first time you people are doing, it took a little bit of time, but it is quite easy. So that is about one charger. It has been started virtually from Visakhapatnam, a charger installed in Rajahmundry, charging my car, my scooter. And if anybody has downloaded this Plug Easy app, I can show that charger also. Or if we don't have time, Subrahmanyam garu, we can skip that because already we have shown one vehicle virtually started from Visakhapatnam. Okay, moving on to the next thing. Calculate the time required for charging an electric vehicle using a portable slow charger. If the C rate, charging rate is 0.2, 0.33 and 0.5. Can somebody say what's the answer? We were talking about this in our presentation also. The charging time required is 1 divided by the C rate. C rate is the battery charging rate. So 1 divided by 0.2 is 5 hours. 1 divided by 0.33 is 3 hours approximately. 1 divided by 0.5 is 2 hours. So as the C rate increases, the charging speed also increases. Nowadays, some of the cars are having a C rate of even 3. Means within a span of 20 minutes, the battery can be fully charged. Then the last question is it true that the charging of an electrical vehicle happens by constant current and constant voltage? What it means here is when you are doing a charging, of any of your two-wheeler, three-wheeler or four-wheeler, the initial charging happens at constant current. Once the battery is approximately 90% of its capacity, it goes from constant current to constant voltage. So the voltage will be like if it is a battery of 48 volts, like Subrahmanyam Garu mentioned previously, the full voltage of that particular battery pack will be around 57 or 57.5. Once the battery reaches a voltage of battery pack reaches a voltage of 57.1 or 57.4, near close to the full capacity, the current trickles down. If the current was previously 3 amps, it will reduce to 2.5, it will reduce to 2.4, like that it comes down to approximately 0.2, 0.1 amps also. Means it will be like a trickle filling. Once the battery pack is totally full, the charging happens as a constant voltage. This is about our session today. Tomorrow also I am having a session on EV policies. So if you have any doubts or if you have any questions today about today's session, you can ask now. If you want to study the things and come back tomorrow and ask any questions which you could not understand or which you need a little bit of more clarity, we are ready to help. Thank you from my end. Thank you for your patience. I understand it is very tough to sit in a workshop after your office hours, wherein you might have been very tired, but this is what we have. It is what we have. Thank you. Thank you, sir.
Thank you very much, sir. So it's been a very wonderful question. So if participants have any questions, they can ask. Otherwise, so you can feel free to post us in the group also. So we will convey it to our resource person, Mr. Ramprasad, so that we can uh, come back to us later on in tomorrow's session also. So once again, I would like to extend our heartfelt thanks to Mr. P.V. Ramprasad Garu for accepting our invitation and presenting this session today.
Okay, sir. Thank you. Thank you very much. Have a great evening. Thank you, sir. Bye-bye. I'm exiting, sir. Thank you.
Thank you, sir.
Thank you, Ramprasad, sir.
Thank you, sir. Thank you.
So, dear participants, now we will move ahead for the session 6, which is hybrid electric vehicles architecture. So, let me have the privilege of introducing the resource person for the session 6, Dr. V. Subrahmanyam Garu. So, Dr. V. Subrahmanyam Garu is an accomplished academician with extensive experience in mechanical and automobile engineering fields. He holds PhD in mechanical engineering from JNTU Kakinada, reflecting a strong academic foundation and research orientation. Currently, he is serving as professor and head of the Department of Mechanical and Automobile Engineering at Godavari Global University, erstwhile known as Godavari Institute of Engineering and Technology at Rajahmundry. So he has been holding that position since 2015. So with over a decade of leadership at the institution, he has significantly contributed to academics, administration, curriculum development, and research promotion, innovation, and departmental growth. So prior to joining Godavari Global University, Dr. Subrahmanyam Garu has worked in numerous well-known institutions, and together he has more than 15 years of cumulative teaching and research experience. His professional strengths include research guidance, training, technical presentations, and academic leadership. In addition to his academic credentials, he has completed multiple certification programs in areas such as design of aircraft and aerospace systems, manufacturing process, architecture, and etc. So, which reflect his commitment to continuous learning and multidisciplinary exposure. He has over 50 peer-reviewed publications in various international journals and several conference papers, 3 book chapters to his credit. Reflecting his innovative skills, he has 12 Indian patents to his credit. Dr. Subrahmanyam Garu continues to be a dedicated educator and administrator, contributing actively to the advancement of engineering education and innovation at Godavari Global University. So we thank you very much, sir, for accepting our request to act as a resource person for our FTP. Being a convener, so you are the backbone of the FTP, and so we thank you very much for accepting to take one of the session with us. So without any further delay, so I hand over the session to Dr. Subrahmanyam Garu. But prior to that, so I would like to just welcome Dr. M.V. Reddy Garu, who is the resource person for session 2 on day 1. So welcome Dr. M.V. Reddy Garu, sir.
Thank you. Thank you.
Yes. Okay, sir. So now I will hand over the session to Dr. V. Subrahmanyam Garu.
Thank you, sir. Srinivas Reddy Garu.
Yes, sir. Your screen is visible, sir. And
Okay.
audio is also good.
Thank you for your introduction. Good evening, all of you. The today's session is the architecture of hybrid electric vehicles. Before going to the topic, let us discuss or let us chit chat some information regarding the necessity of electric vehicles and the hybrid electric vehicles. These pictures are showing the first automobiles in the history. The first one is a steam engine. The steam engine operated automobile that is in the year of 1769, which is prepared by the Cugnot. He is a French military engineer, and of course, it ran for a distance of just 15 feet only, and then it is stopped. Still, that is in the French museum. It is said to be the first automobile in the history, and that the next one is the Puffing Devil. It is a British inventor, Mr. Richard Trevithick, in the year of 1801. He ran that vehicle on the London roads, and after that, one thing is everyone is feel that the first automobile is the automobile which is manufactured by the Benz, but that is not true. But the most of the automobiles are running with IC engines, so they are feeling that the first IC engine vehicle is the first automobile in the history. But prior to that, there is a lot of automobiles are there. In this picture, you can observe the steam engine operated automobiles, and after that, I think the cursor is visible to you. Srinivas Reddy Garu, any one of you please respond.
Yes,
Is
sir. The cursor is visible.
Okay, this one is the battery electric vehicle. Okay, this battery electric vehicle is manufactured in the year of 1830. But that battery electric vehicle is the first invention much before than the IC engine automobile. That is in the year of 1830, and these battery operated vehicles are manufactured. Actually, with the diagram, you can observe that actually that is a buggy. The buggy means which is pulled by the horses. Okay, without horse, that vehicle is driven by means of electric motor. That electric motor is powered by means of non-rechargeable battery, and the last one is said to be the first automobile in the history, that is a tricycle, which is manufactured by Carl Benz. He took the patent for that in the year of 1886. Okay, and next one, these are the first hybrid vehicles, which is manufactured by Porsche. He is also from Germany, and this is also the hybrid vehicle in the history. It looks like a muscle car, and the muscle cars ran on the road in the year of 1960 or 1970 itself. And one question, dear participants, you kindly respond in the chat box, or you can give the thumbs up if it is correct. Otherwise, you can give thumbs down if it is wrong. Okay, are these hybrid vehicles? Here, a wagon-R which is run by the petrol and also a gas. The gas is a CNG gas, compressed natural gas. Is it a hybrid vehicle? No. This is a dual fuel vehicle, not a hybrid vehicle. Yes, sir. It's a dual fuel vehicle, not a hybrid vehicle. In the second figure, it is showing that E20. You might have seen a E20 on a vehicle, petrol tank cap. Okay, what is that vehicle? Actually, most of the bikes are coming with E20 and the cars are also coming with E20. E20 means 20% of methanol in petrol. That fuel is classified as E20. 20% methanol. Methanol is a biofuel which is blended with the petrol. So that is called a dual fuel. But the E20, actually the new vehicles are designed to operate with the fuel of E20. But the old existing vehicles are not designed for E20 fuel. So we are facing some problems with that type of fuel also. Any other gas, any other vehicle which is running by some other gas, can anyone list out? Other than the Suzuki company, the Suzuki company is giving a verified the gas kit also, that is CNG gas kit. But the Hyundai vehicles are coming with LPG, liquefied petroleum gas. Okay. And here I am giving the definition for hybrid systems. What is a hybrid system? The hybrid system means a machine which is operated by dual fuel is called a hybrid vehicle. A dual energy is called hybrid vehicle. The dual energy means here this is a comic, just a comic. Suppose a car is driven by an IC engine and also can be pulled by a bullock or a horse, that can be classified as hybrid. Okay. For example, if a bicycle is fit with an IC engine, that bicycle can be driven by means of IC engine and also can be pedaled. So the bicycle can be driven by means of muscle power or the engine or heat energy. Okay, so that can be called as a hybrid vehicle. Some vehicles can be driven by means of electrical energy and also heat energy. Those vehicles are classified as hybrid systems. These are some other already existing hybrid systems much before than the automobiles. See, the left side one is a submarine. The submarine can be driven by means of electric motor and also the diesel generator. Actually, that is driven by the electric motors. The diesel generators are used to charge the batteries to operate this electric motor. And the right side one is a locomotive, that is a train engine, which is also a hybrid system. This engine it is not an electric locomotive, it is a diesel locomotive. This diesel locomotive can be driven by means of an electric motor and which is operated by means of battery. Those batteries are charged by means of diesel engine generator. Okay. And let us see the configuration of an IC engine. You already know the IC engine vehicle is driven by means of an IC engine. It consists of clutch, gearbox, propeller shaft, and so on. The power is transmitted to road wheels and which is driven by means of the mechanical energy. Here the IC engine is operated by means of fuel. The fuel may be petrol or diesel or biofuel, whatever it may be. The fuel tank is the energy storage device and the IC engine is operated by means of by burning of the fuel. Okay. And this one is the battery electric vehicle. In the battery electric vehicle, there is a battery, electric motor, and road wheel. Okay, so this is a pure electric vehicle, and this is a pure IC engine vehicle. Suppose if we club together these two things, then it becomes a hybrid system. In the hybrid vehicle, it is a hybrid vehicle. Here there is an IC engine as well as electric motor. This vehicle is driven by means of the IC engine and also electric motor. So it can be called as a hybrid electric vehicle. These are some architectures of electric vehicles. In the electric vehicle, this is the front portion. The arrow mark is indicating the front portion. This is the steering wheel. So this is the back axle. In the back axle, see, the electric motor is connected to the back axle. So the vehicle is a back wheel drive vehicle. Here there is only one electric motor which is used to operate the vehicle. So it needs a differential. The differential is used to get the differential motion to both the wheels. Okay, otherwise the vehicle cannot take turns easily. Okay, and in the second picture, it is showing that each wheel is provided with a separate motor. So there are two motors which are connected to both the wheels. And in the third case, the front wheels are arranged with the electric motors. Suppose if we are using a dual motors, it is a dual motor drive mechanism. There is also differential is needed. How differential action is obtained? The differential action is obtained by means of electronic circuitry, which is incorporated with the steering wheel. When the steering wheel is rotated, with the angle through which the steering wheel is rotated, the differential power supply is happened in the electric motors. So the inside wheel receives less amount of power and outside wheel receives more amount of power. So the outside wheel will run faster than the inside wheel. In that way, the differential action is obtained. In some cases, the electric motor is incorporated inside the wheel. In such case, that is called a hub motor. Okay, so this is the electric vehicle architecture. Okay, these are the different types of electric vehicles. The abbreviations for electric vehicles: FCEV, the fuel cell electric vehicle. Actually, yesterday some speakers already explained the fuel cell vehicles, and BEV is a battery electric vehicle. REEV, this is a range extended electric vehicle, plug-in electric vehicle, ultra capacitor electric vehicle, and ultra flywheel electric vehicles. Okay, we can see them later on. Okay, first the first question is, already electric vehicles are there. Why we are going for hybrid vehicles? See, actually, electric vehicles are costly than ICE engine vehicles. So hybrid vehicles means hybrid vehicles are combining both the features of electric vehicle and also the ICE engine. So the cost of the hybrid vehicle will be sum of the cost of electric vehicle and also ICE engine vehicle. Not exactly. Definitely a hybrid vehicle cost will be more than an ICE engine vehicle and electric vehicle. though electric vehicles are available, why we are going for hybrid vehicles? Okay, first of all, let us see which one is eco-friendly. Could you please judge which one is eco-friendly? If you feel electric vehicle, you can give a thumbs up. Okay, so actually, electric vehicles don't have tailpipes. So we are feeling that electric vehicles are clean vehicles, but the electric vehicles are driven by means of electrical energy. That electrical energy is obtained from the domestic current or any charging station. They are getting electrical energy from the power plants which are driven by means of fossil fuels. Okay, they may be in India, most of the power plants are the coal-based power plants. So, though the electric vehicles are not causing pollution, direct pollution, indirectly they are causing pollution through the power plants. Okay, so the electric vehicles cannot be treated as the pure electric vehicles and they are eco-friendly. And moreover, the electric vehicles are driven by means of the batteries. Those batteries, after lifetime of those batteries, they are causing a lot of pollution to the earth. Okay, so electric vehicles are not at the clean or pure eco-friendly vehicles. So that's why we are going for hybrid vehicles. Otherwise, we cannot move to hybrid vehicle. Why hybrid vehicles are better than electric vehicles? So the hybrid vehicles are better than electric vehicles, and electric vehicles are better than ICE engine vehicles. Okay, this is the correct answer. To see how the hybrid vehicles are better. Actually, most of the mechanical engineering faculty already know that in the automobiles, the fuel is sent to the engine according to the load and speed conditions. Suppose the load is high, a high amount of fuel need to be sent. When the load is high, during starting, there is a very high amount of friction is there. So during starting, we need to give high amount of fuel, and during acceleration also we need to give high amount of fuel. During normal running only, the engine is consuming the moderate amount of fuel. Okay, so the engine is consuming a rich fuel during starting and acceleration. Suppose the vehicle is run by means of electric vehicle during starting and acceleration, and during normal running, if you are using an IC engine, then you can decrease the pollution from the automobiles. Okay, why? Because the engines are having a certain speed at which they are producing a very little amount of pollutants. So the engine is designed, the vehicle is designed to operate at such optimum speed so that we can decrease the pollutants. Okay. So during starting and acceleration, we can use the electric motor, and for normal running, we can use IC engine. So that type of vehicles are called hybrid vehicles. Actually, what are the challenges with electric vehicles? Electric vehicles, the main challenge is their range. Actually, we are having range anxiety. Suppose if the manufacturer is given a 150-kilometer range of vehicle, suppose you have given a range of 150 kilometers. Suppose if you need to go for a 50 kilometers distance, we feel doubt. Suppose if we could not come back with the battery charging, suppose the battery charging is not not enough for the city running, then what to do? Then the vehicle need to be towed back to our home. It is a very costly affair. So nobody is daring to bring their electric vehicles to the intercities. They are using the vehicles only inside the city. Though, if suppose if it is a big city, we are not there to go to at least the city outskirts. So that is the main problem with electric vehicles. But some vehicles are coming with a better range of 200 kilometers or 300 kilometers. But that is also not enough to go for one city to another city. Okay. So, and another one is lithium ion battery. The lithium ion battery is, everyone is feeling that the lithium battery is not safe. Actually, daily we are watching that the cell phones batteries are exploding. Suppose the lithium ion battery of our vehicle gets exploded, then what happens? Everybody is worrying about that. Okay, and the cost of the electric vehicles are also high. So government is encouraging and giving some introducing some policies. What is that policy? Can anyone reply? What are the famous policies which are given by the government? And this one is these are the vehicles. Yes, sir. Raju Kurian Daniel, sir. Very nice, sir. Your answer is absolutely correct. And these are the vehicles. In the famous vehicles, the first one is a Ford Mustang, and the second one is Harley Davidson bike. This is an electric bike, but these two are also developed to operate with electric motor, but they are not become popular. But why? Actually, these vehicles came into market 10 years back, 10 or 8 years back, but then didn't popular. The full form of FAME is faster adoption and manufacturing of hybrid and electric vehicles. FAME 1 is over. Actually, every year the government is modifying on the policies, and the FAME 1 and FAME 2 is also FAME 2 is running, I think. And these are the electric vehicles in India: Tata Nexon EV, Tata EV, Tiago, Mahindra XUV, BE, Hyundai Kona, and so on. And can anyone recognize this electric vehicle which is given in the picture? Its name is not given, is not listed here. What is the name of it? Suppose if you recognize, you can keep it in the chat box. It is the most popular electric vehicle at present. That is Tata Curvy. And why hybrid vehicles? The Toyota Prius is a famous hybrid vehicle. The Toyota in the market. Yes, sir. Nagmaneswar Rao, sir. Yes, that Tata Curvy is an exact answer. Yes. And why hybrid? The Toyota Prius. And the Toyota Prius is coming with different configurations, and one vehicle is with a normal petrol engine, and another one is a hybrid system, electric hybrid vehicle. The electric hybrid vehicle is giving 29 km per hour of mileage, and the normal engine is giving 18 km per liter of mileage. So you can see the difference. There is more than 10 kilometers difference is there. So that's why the hybrid vehicles are becoming popular than electric vehicles. And these are the publicity posters. The first one is a Ciaz. Which manufacturer is manufacturing Ciaz in India? It is a Suzuki model with the collaboration the Ciaz is producing. It is a and they are claiming that it is a smart hybrid diesel car in India. That is the first smart hybrid diesel car in India. It is a Suzuki vehicle. And the second one is a iSmart 1 ton. Which model it is? Can anyone guess? It is a Splendor, Hero Splendor iSmart 110. These are, yes sir, Nagamanaswara garu, correct sir. Okay, actually these are not the fully hybrid vehicles. They are, it is a first step of hybridization. And let us see what are the different types of hybrids. Broadly, they are classified into 3 types: micro hybrid system, mild hybrid system, and full hybrid systems. The micro hybrid system, the Hero Splendor comes under the micro hybrid system. It is having a iSmart system. The iSmart means it is a smart start and stop system. Suppose the vehicle is keeping in idle for more than 1 minute, the engine will be automatically stopped. And whenever we hold the clutch, the engine gets started. Okay, it can be started very smoothly. So that system is called iSmart system. So in that way, it is saving the fuel. Suppose the vehicle is stopped at the signal at junction for more than 1 minute, the engine will be stopped, and the engine can be easily started when you hold the clutch. And some vehicles are provided with regenerative braking systems. RBS means regenerative braking system. And some vehicles are also provided with the torque assist system. And next one is the mild hybrid systems. And this Suzuki Ciaz comes under the mild hybrid system. See in this diagram, in the actually it is a publicity poster in a newspaper. Here, 2 components are highlighted. See, one is the battery, and the second one is this device is a starter generator system. Actually, in the automobiles, the engine consists of 2 main electric devices. One is a starting motor, and another one is alternator, that is generator, to charge the battery. This device is replacing those 2 elements. This is a single device which is replacing those 2 elements. This device can be operated as starting motor as well as generator. During starting, this device is used to start the engine, and during running, this device develops the electricity and is used to charge the battery. Okay, so that system is called integrated starter generator system, ISG. And during braking, this same device is used to generate the electrical energy, and which is used to charge the battery. And the battery is a 48-volt battery. It is a less capacity than a fully hybrid electric vehicle. And there is no electric drive alone. The vehicle cannot be driven alone with the electric motor. And there is this motor is used to power assist. Actually, these vehicles, some vehicles which are manufactured by the Suzuki company, don't have the superchargers. Actually, what is the purpose of a supercharger? The supercharger boosts up the power. Suppose if we are boosting up the power, means we are sending a huge amount of fuel to the engine. Suppose if you send a huge amount of fuel, automatically it will emit a huge amount of gases or the pollutants, and thereby it is causing pollution. Suppose if we replace this regenerative brake, this integrated starter generator system, this starter generator system boost up the engine while starting or accelerating, so that you can replace that supercharging methods or the turbocharging methods. Okay. So most of the Suzuki vehicles are provided with integrated starter generator, and they are avoiding the turbocharger or superchargers. And we already discussed this vehicle is having a battery electric motor. That means it is a battery electric vehicle, not a hybrid system. Let us see. Suppose if you want to make it a hybrid vehicle, then what to do? Then we need to incorporate a generator. See, actually, you consider this one, the previous one. It's an electric vehicle. Suppose the manufacturer is given a range of 100 kilometers. So the battery will last for 100 kilometers. Suppose if you need to go to a 200 kilometer distance, then what to do? Suppose there is no charging points in between your destination and the starting point, then what to do? You need to carry a generator. Suppose if you carry a generator, then see, it's a generator. See, it's a generator. That generator generates the energy and which is used to charge the battery. Suppose if you carry a generator which is external to the vehicle, it can be called as the name. Anyone guess what is the name of it? It is a generator. The generator consists of a prime mover and a generating device. The prime mover means an IC engine and a generator. Okay. So what it is, with some name it is called as what is its name? It's a famous name, that is range extender. Here we are increasing the range of the vehicle by carrying a generator, an electric generator. So that is called a range extender. So after suppose the batteries ran out, you need to stay there at some place and you need to start the generator. So the generator can charge the battery, and then after recharging the battery, you can come back or you can continue your journey. Okay. Then what is the benefit with this IC engine or electric generator? Actually, the IC engine is also causing pollution. Then what is the benefit with hybrid system? The benefit is here the IC engine is running at a constant speed of and the optimal speed at which the generator is producing less amount of pollutants. So obviously, the vehicle is emitting very least amount of pollutants by operating the electric generator at a constant speed. Okay. So this type of vehicle, that vehicle can be called as hybrid vehicle. Suppose if you purchase an electric vehicle, the electric vehicle means which is driven by electric motor. Suppose if you are carrying a generator along with your vehicle, then your vehicle can be called as a range extended electric vehicle, REEV. Okay. In hybrid electric vehicles, there is a different types of hybrid electric vehicles. There are series hybrid electric vehicles, parallel hybrid electric vehicles, and combined series and parallel hybrid electric vehicles. Again, in combined series and parallel, there is a ICE engine heavy series, electric heavy series. Two types are there, and the fourth one is complex hybrid electric vehicles. In complex hybrid electric vehicles, front hybrid, rear electric, front electric and rear hybrid, two types are there. Let us see one by one. The left side is the series hybrid electric vehicle and the right side is a parallel hybrid electric vehicle. In the series hybrid electric vehicle, see, there is an electric motor which is coupled with the back side of the axle, the back axle or whatever it may be, the front axle or back axle. And the motor is operated by means of battery. Okay, M is electric motor and B is the battery. The battery can be charged by means of a generator which is driven by an IC engine. Okay. So here, what is the power flow? First, the engine is operated. Engine is operated means the power is transmitted to generator. From generator, the electric power is transmitted to battery. From battery, the power is transmitted to motor, and from motor, the power is transmitted to wheels. So here the flow is in series. So it is called as series hybrid electric vehicle. So here the motor is used to drive the vehicle alone. Actually, the engine is not contributing directly in the motion of the vehicle. The engine here, that we are using the engine to recharge the battery only and not to transmit any power to the vehicle. So here this is called the series hybrid electric vehicle, which is operated by electric motor alone. Okay, and the second one is parallel hybrid electric vehicle. In parallel hybrid electric vehicle, see, this is an IC engine. The blue color is a IC engine, and the red color is a electric motor with battery. These two are connected to the axle, the live axle of the automobile. So the power is half of the power is developed by IC engine, and half of the power is developed by the electric motor. Okay, so these are called parallel hybrid electric vehicles. Suppose the batteries ran out, then what happens? You can run the vehicle with IC engine, but not with full extent. It cannot develop the full amount of energy. It is developing only half of the amount of energy. So the vehicle cannot run with this full performance. Okay. So here we need to recharge the battery. How to do? Here the motor may be a regenerative braking system. During applying brakes, the electric motor generates energy and is used to charge the battery. But that energy is not enough. So we need to carry again some generator along with our automobile. Okay. So that's why the manufacturers are think about this problem, and they arranged a generator along with these systems. See, I'm turning the slide. See, the parallel hybrid electric vehicle. The left one is again the series one. I didn't change the picture at the left side. In the right side picture, see, only the difference is generator. The previous one, this one is a parallel hybrid electric vehicle, and this one is series parallel hybrid electric vehicle. It combines both the features of series and parallel. Here, the generator, which is driven by means of the IC engine. So, IC engine is used to operate the generator and also drive the vehicle. So, here the IC engine is somewhat bigger than the previous case. Okay, here the generator generates the energy and is used to charge the battery. So this type of system is called a series parallel hybrid vehicle. Why? Because see, the energy from IC engine, the power is transmitted to generator, from generator to battery, from battery to motor. So it became series. And again, see another path, IC engine to axle and electric motor to axle. So this is parallel. So this configuration is called as series parallel hybrid electric vehicle system. Okay, once again, I am explaining. In the series hybrid electric vehicle, the IC engine is used to drive the generator, and generator developing energy which is used to charge the battery, and battery is used to run the electric motor. From electric motor, the power is transmitted to axle. So this is a series path. In parallel, the electric motor and IC engine are connected parallelly to axle. And in series parallel, the power is transmitted one way is through the generator, the power is transmitted to electric motor and to axle, and parallelly the power is transmitted to axle. So it combines both the features of series and parallel hybrid electric vehicle. And this is again the same diagram with two different types. The two different types are some cases the IC engine is heavy, in some cases the electric motor is heavy. Suppose the IC engine is heavy, during normal driving, the vehicle is run by means of IC engine only. Normal driving means at optimum speed, only the IC engine is operated. Optimum speed means that is approximately 60 to 80 km per hour. At that speed, 50 to 80 kilometers hour of speed may be optimum speed for an IC engine. At that speed, the vehicle is operated by means of IC engine. And during in case of electric heavy series parallel hybrid electric vehicle system, during normal running, the vehicle is run by means of IC engine as well as electric motor. Okay, that is the difference between the IC engine heavy and electric heavy. In IC engine heavy, the vehicle is run by means of IC engine during normal running. The remaining means the starting, acceleration or braking, the vehicle is run by means of electric motor. In electric heavy vehicles, they can be charged while stalling also. That means while the vehicle is stopped also, the battery can be recharged by means of the engine. This one is a front engine rear hybrid. FERH means front engine rear hybrid dual axle complex hybrid electric vehicle. Okay, simply speaking, complex hybrid electric vehicle. In the complex hybrid electric vehicle, see, this is the front side of the vehicle and this is the back side of the vehicle. Okay, at the front side of the vehicle, there is an electric motor which is used to transmit power to front axle. At the back side, this is the electric motor and engine. These two are coupled together and are used to transmit power to back axle. Okay. So the front drive is a purely electric motor drive and the back wheel is a hybrid drive. So this is called as front this one front electric and rear hybrid. Front electric and rear hybrid. Okay. At the back axle, which is driven by means of both engine and electric motor. So this is a hybrid drive, and the front electric motor, this is only the front axle is driven by means of electric motor. Okay, when the electric motor come into picture, see during starting and acceleration, the vehicle needs a huge amount of power. So during starting and acceleration, the electric motor is used, the front motor always runs during starting and also acceleration. So it gives additional amount of boost to the vehicle. And the rear hybrid system, when it comes into picture, see during acceleration, normal driving and battery charging, this hybrid system is operated. How the charging happens here? Here, when the engine is running, the electric motor also runs. These two are coupled together. Suppose the vehicle needs additional amount of energy, they will send energy to the axle. Suppose if the vehicle don't need that much amount of energy, that energy is the motor acts as generator and is used to recharge the battery. Okay. And this is a front hybrid rear electric. In the previous case, see this is the previous case, this is the front electric. Suppose if we reverse the diagram, that means the front portion is equipped with a hybrid system. The hybrid system means engine and motor coupled together and are connected to front axle. And the rear axle is operated by means of electric motor only. Here, when this hybrid system comes into picture, see during starting, during light loads, during acceleration, during retardation, this system comes into picture. That means during entire time, the system will always run while running the vehicle. The rear device, see the electric motor, will only operated during startup and acceleration. So this single electric motor is used to balance the energy, that is used to boost the energy to the vehicle. You can see these are some of the examples of the famous models: Chevrolet Volt, Honda Insight, and Toyota Prius. Okay. Can anyone recognize the architectures? Which architectures are these? The first one, Chevrolet Volt. See, the engine. The engine power is transmitted to generator. From generator, the power is transmitted to inverter and to the battery. And from battery, the power is transmitted to electric motor. From motor, the power is transmitted to axle. So here the path is engine, generator, battery, motor, axle. So which model it is? Series or parallel?
Series, sir.
Series. Yes, sir. The power is transmit. Yes, sir. Very good. The power is transmitting from engine to generator, battery, motor to the road wheels. So it is a series. Okay. In the second case, the Honda Insight, this is the engine power is transmitted to motor and to the axle. Here, the motor is used to recharge the battery and also to send power to road wheels. So it is a complex drive. Actually, in a complex drive, one axle is driven by means of hybrid system and another axle is operated by means of pure electric motor. In only complex drive, the engine and motor are coupled together. So here the power is transmitted from engine and motor directly to wheel, means it is a complex drive hybrid system. And in Toyota Prius, say engine, here also the power is going to generator and also motor. So here the engine is used to operate the generator as well as motor, means it is neither series nor parallel. Okay. So actually we have gone through several architectures. One is a series hybrid vehicle, parallel hybrid vehicles, and series parallel, it is a combined feature, and IC engine heavy, electric heavy, dual axle. In dual axle, again complex hybrid at front axle and complex hybrid at rear axle. Though we have gone through several architectures, there is some more architectures are also there, depending on the type of the vehicle. So these architectures plays a vital role in getting a better performance at cheaper rates. Actually, the hybrid systems are, we already discussed that hybrid systems are much more costlier than ICE engine vehicles and electric vehicles. But here, the energy is balanced by means of electric motor and also ICE engine. Suppose that means the engine is not of that much bigger, and also the battery, the electric motor is also not of that bigger electric motor as in battery electric vehicle. So with the a small size of IC engines and small size of electric motors, we are driving the vehicle in balanced mode. So and they are causing a very less amount of pollution to the environment. Okay. In the at first we discussed some of the types of electric vehicles. In the electric vehicles, one type of electric vehicle is ultra flywheel electric vehicle. In ultra flywheel electric vehicle, see here, this is a simple example of a flywheel vehicle system. Here, this is a flywheel. A flywheel means a massive wheel, just like an engine wheel, an engine pulley or engine wheel, which is also rotated while pedaling the bicycle. Okay. When you stop pedaling, this pulley delivers the energy which is stored in it and drives the vehicle. Okay, so that is called ultra flywheel vehicles. Actually, these ultra flywheel systems are used in sports vehicles. They are successfully used in sports vehicles. Actually, the sports batteries, actually the sports vehicles are actually started by means of a battery which is their garage, and the vehicle is started by means of race vehicles are avoiding the batteries. Okay, so during running, uh, uh,
Sir, we have taken your point.
when the
What
engine is idle, this flywheel delivers the energy. Okay, so that type of vehicles are called ultra flywheel electric vehicles. Actually, this this session is the topic is completed. Actually, the topic actually, what is our topic? Our topic is only architecture. The architecture is finished, but what the takeaway with this architectures? In the architecture, we have gone through several models which are connected, which the systems are connected, interconnected, and the systems means the electric motor, battery, generator or IC engine and axles, how they are connected, interconnected. So with that, how the performance is improved. Okay, so the hybrid systems are definitely superior than the electric vehicles and also the IC engine vehicles. They are already proved. So we need to optimize the cost of the electric vehicles. So in that way, we need to do research to optimize the cost of the hybrid systems. Here, what we have done in our Godavari Global University in the in the mechanical engineering and also automobile engineering, here we developed some models. I am presenting some of the models which we are developed from the past 4 or 5 years. And see, this one is a pure electric vehicle, which is driven by means of electric motor, which is incorporated inside the wheel. So this is called a hub motor. The hub motor is a DC brushless DC motor, hub motor, and at the rear side there is that is having two dummy wheels. So it can be operated in the plants. Suppose where suppose the industries, there is lot of distances are there to cover the supervisors or the workers. So we can use such type of vehicles. Okay, and the second one is it's a bicycle which is developed by the students, which is just like a chopper bike, and which is driven by means of the IC engine as well as the pedal power. So with which name we can call it as? Is it an IC engine vehicle or bicycle or hybrid vehicle?
Hybrid, sir. Hybrid.
Yes, sir. And this one is driven by means of IC engine as well as pedal power. Okay, suppose the fuel is ran out, this is the fuel tank. Suppose the fuel is ran out, then the bicycle can be pedaled. So this can be called as a hybrid vehicle or hybrid bicycle. Or sometimes the engine may be replaced with the electric motor also. And this is a this design is totally done by the students of the Godavari Global University, and this is just like a moped. and the batteries are inserted into this lengthy component and which is supported with the two wheels handle, and it is a simple model. It is a and the motor is incorporated inside the back side of the wheel. Okay, this is just like a moped, and this one is uh, the first Ford T model, the replica of the Ford T model. And here the left side, this car is developed from zero level. The zero level means the chassis and body is totally built by the students, and the body is made from. Can anyone guess the material of this body? This body is made from wood, plywood. Okay, the plywood is bent like this and made the body is made totally made from plywood. The chassis is made from of course the mild steel box sections, and this vehicle is driven by means of an engine, and the engine is powered by means of petrol as well as the hydrogen fuel. We purchased the hydrolysis kit in the Amazon, and in the hydrolysis kit that is operated by means of battery. If you connect the battery to the hydrolysis kit and if it is filled with water, it will split the water into hydrogen and hydroxyl ions. So the hydrogen can be lifted up through the bottle, and suppose if you send the hydrogen to the engine through the intake manifold, the mileage of the vehicle can be improved. So that this vehicle is partly driven by means of petrol, and that hydrolysis kit, that means water, not with pure water, partly with water, so that we observed the improvement in the mileage. Actually, alone that engine is giving a mileage of 35 kilometers, and by incorporating that kit, an improvement of 5 kilometers is observed. But in news, you might have gone through some news articles. Someone is driving his vehicle with pure water. Actually, that vehicle is ran with that vehicle is equipped with that type of hydrolysis kit. That hydrolysis kit separates water into hydrogen and hydroxyl ions. But that vehicle is not purely run by water. Again, that is partly run by hydrogen fuel. But suppose if your vehicle is running with water, that means hydrogen fuel, is there any problem? Can anyone expect any problem with the hydrogen fuel? Suppose if you burn the hydrogen is converted into water. So hydrogen combines with oxygen and again the hydrogen forms water H2O. That water is causing pollution. The water is causing corrosion to the engine. And the engine, actually, the petrol engines are made from aluminum alloys. The aluminum alloy may not corrode, but the inside portion of the engine may be subjected to pitting. That means the particles may be removed from surface. And why? Because the hot body is exposed to the cool water. Suppose if it is forming water, the chilling action causes the pitting. That is the problem with hydrogen fuel. So that's why, though the enthusiasts are running their vehicles with hydrogen kits, they are not becoming popular. No manufacturer is daring to market the vehicles with hydrogen kits. And the second one is also a tricycle. Here in the previous slide, we have seen the similar type of vehicle, and the tricycle which is driving with an electric motor at the front side, and the back side there is two dummy wheels. But here the front wheel is a dummy wheel and the back two wheels are driven by means of electric motor. And this one is and this design is for carrying the needy people at for example in the airports or railway stations or shopping malls. And the attendant can stand at the backside of the chair and we can carry the patients or and the oldest people, the needy people. And here this the front portion, the wheel is driven by means of electric motor and the back wheels are dummy wheels. Okay. And this wheel can be this wheel along with the seat can be turned by means of the handle. This is the handle. And these are some interesting vehicles. See, these are the classic bikes, the most famous bikes. I hope all of you recognize these bikes. The left side is RX100, Yamaha RX100, which is collected from the scrap, and the right side one is Hero Splendor, which is also collected from the scrap. And they are their engines are removed and they are equipped with electric motor and batteries. You can see this is the electric motor which is equipped inside the wheel, the back side of the wheel. And here this is the electric motor which is connected to back wheel. And these are the batteries. This is green color are batteries. And there are 4 batteries. Actually, each battery is a 12 volt capacity battery. Those batteries are sealed lead acid batteries. So each battery capacity is 12 volts means totally the 4 battery voltage is becoming 48. 12 into 4 is 48. Here you can easily observe that the 4 batteries 1, 2, 3 and 4 and each battery capacity is 12 volts. So totally they are connected in series means totally it is producing a voltage of 12 into 4 48 volts. Actually these motors are 48 volt DC motors. They are hub motors. So these type of vehicles are called converted vehicles. Actually, you can suppose if you are having a outdated bike. Suppose if you are you admire your bike, you don't want to scrap your bike, then you can convert your bike into electric vehicle. And we can run the electric. You may have doubt. Shall we run the vehicle of outdated bike? Actually, you can run the bike. Suppose if it is equipped with an electric motor less than 500 watt motor. Actually, these motors are 500 watt motors. The 500 watt motor comfortably can pull a single person with a load of uh, uh, an additional load of 50 kg also. We ran the bikes inside our campus and still we are using these bikes in the campus. And these are the some models. These models are actually for the purpose of the people who are residing at very interior areas. Some areas are not connected by means of roads. In those areas, even the ambulance also cannot go. In such areas, the patients can be brought. Suppose in emergency, the patients can be brought by means of these type of vehicles. The left side one is actually a single cart. This cart can be pulled by means of a bike or even a tractor. So in emergency, the passengers can be carried by using this vehicle. And the right side one is an attachment which can be coupled with a bike. Okay, so the patients in the interior areas and the agency areas can be easily carried. So these type of vehicles can be called as um, and the feeder ambulance. And this model is uh, this model and the by using this vehicle can be used by the farmers or the street vendors for carrying, useful for urban people. Okay, nice finish. Suppose if you have any.
Thank you very much, sir. So, participants, if you have any questions, you can ask. The session is open for Q&A.
Good evening, sir. I have one doubt, sir.
Okay.
Sir, what is a stop and start system in the hybrid vehicle, sir?
Yes, madam. The start and stop system means actually that is a smart start system and a smart stop system that is called as a smart system. Here we are using a starting motor which can also be used as a generator. Okay. So this is called integrated starter generator system. That unit system is replacing the starting motor and also the generator. Okay. So suppose while starting, when you switch it on the start button, the generator is rotated, acts as starting motor and is rotated and rotates the engine so that engine can easily start. Okay. When during retardation, that device acts as a generator and produces electrical energy. Actually, the device runs along with the engine continuously, so it produces electrical energy which is used to store, which is used to recharge the battery.
Okay, sir. Okay, thank you, sir.
Thank you.
Any other questions?
Because the participants actually we are actually doing research in hybrid systems is a costly affair. Yesterday, one participant asked the resource person to submit a research proposal. Actually, during doing the research in the hybrid system is a costly affair. We are observing that the automobile, the hybrid vehicles are actually, suppose the IC engine vehicle is of a particular model is of 10 lakh rupees. The electric vehicle of the same capacity is around 15 to 25 lakhs. And the hybrid system is more than 25 lakhs. That is around 30 lakhs rupees, even 35 lakhs also. So actually doing research in that area, actually giant automobile industries are working on hybrid systems. So there is a lot of research is happened and still the research is going on. So doing research in the type of hybrid systems is a very tough task and that is beyond our scope. Actually, I'm not discouraging. Suppose if we want to do the research in such areas, we need to collaborate with those giant companies. So the research is a difficult task, but we can do the models. That's why I have shown the different models here. These models actually the electric vehicles are outside. You can see very least number of models. The model means and there is a car and there is a bike, there is a scooter. That's it. Not more than that. Only you can see electric scooter, electric bike, electric car. But electric autos are also we can observe, but the electric different applications are also be there. We are using different types of vehicles for carrying the fruits. The street vendors are used to carry the fruits. The street vendors are milk. Okay, and the farmers are used to carry ureas or the yielded the products they are carrying by using the vehicles. But the electric vehicles which are available in the market are not able to cater their demands. Okay, so if you design a model uh, to match to suit the requirement of those people, definitely your invention may be your design will be definitely hit the market. Okay, so that's why we are focusing on the different models of the vehicles for different applications. Uh, okay, so if any participant is interested to do the collaborative work with us, you are mostly welcome, and you can come to our university, or you can meet us, or you can call us directly, so that we can do the miracles. Okay, so and that's it from my side. So Srinivas Reddy garu, if you
Yes, sir. So, yeah, thank you, sir. So, if there are any other questions, so feel free to post it in the group so that we can convey the same to. Sir, so we have a question from the participant. In the chat box, we have a question.
the chat box. Future hybrids in real world Indian conditions when EV are becoming widespread. Actually, hybrid vehicles are also be observed on the roads, but due to the cost, they are not attracting. Actually, for Indian conditions, they are much more costlier. Actually, the people and we are focusing on the vehicles which are their cost is around 10 lakh rupees. So we are not able to, and the country, the people are not able to afford that much of cost. But the affordability of the people are increasing, but definitely on one day they will definitely come to our hand. Actually, the people 15 years back. We are not able to purchase a Nokia phone. Actually, that Nokia phone cost is around 8,000 rupees at the time. But that model phone is coming with a cost of 800 rupees nowadays, even 500 rupees also. So after the continuous work on it, definitely after some time, they will also, and their cost also can be cut down, and they can be afforded by the common people. Yes, can we replace the EV vehicles with petrol and diesel? Yes, sir. Actually, at the Tirupati, we are using electric buses. I think most of the participants observed it. When you are getting onto Tirupati, before five years back, there is diesel buses are there, but nowadays we are using electric buses to go on to the Tirupati, and the electric buses are also observed outside. And the FAME 2 phase, the government had given a lot of subsidy, so um, the RTCs are the state government RTCs are also able to purchase the electric buses. Those electric buses are giving a mileage of more than 150 kilometers, and they are also coming with fast charging. And we are also observing the electric buses outside also. The rear engine buses are why not used? The rear engine buses are using, sir. Actually, Volvo buses and Scania buses are rear engine buses. But Indian buses are Indian manufactured buses means the Tata buses and Ashok Leyland are front engine rear wheel drives. We are actually those capacity is 150 horsepower and so on. The Volvo and Scania buses are much more bigger buses. Their comfort is different. Their weight is also different. And these buses, Tata and Ashok Leyland buses, are somewhat lighter than Volvo and Scania buses. For that architecture, the front engine rear wheel drive is giving much stability, and they are giving much comfort, and also the people are actually not able to adjust the new models. Actually, the people are feeling comfort with front engine and rear wheel drive vehicles only. But the Volvo and Scania buses are rear engine vehicles. How is NVH, noise, vibration, and harshness managed in hybrid vehicles? Actually, the vehicles are the electric vehicles are much silent and vibration-free vehicles. But suppose the electric motor capacity is high, they are causing much noise also. That noise is uh, not actually the engine IC engine sounds are very impressive, but electric motor sounds are too noisy and they are causing very disturbance to the passengers or the pedestrians on the road. You can observe the sound of electric Formula E cars. They are producing much noise. Why? Because their motors are very high capacity motors. That motor is generating actually in Formula E car, the rear axle is provided with one electric motor and the front axle is provided with another electric motor. Two motors are there, and each motor is developing a power of 600 horsepower. Totally, that is developing 1200 horsepower. The 600 horsepower means that is causing much noise. But these see the Suzuki vehicles are Toyota vehicles or Honda vehicles. Their capacity is only 100 to 150 horsepower only. So actually, the electric motors are torque is very higher than petrol and diesel engines. So there the 100 horsepower is enough for us. So that those electric motors are not producing much noise and vibration. So those vehicles are very smoother in operation. And the only problem is the power splitter. The power splitter means in the parallel hybrid vehicle, we have observed that the IC engine power is split up and some part of energy is going to axle and some part is going to generator. Okay, there is a power splitter. That power splitter is also engaged very smoothly. That is a planetary gearbox type, which is operated by means of an onboard computer system. Onboard computer system means embedded system, which can be easily operated, that automatically operated without any human interaction. Yes, sir. The electric vehicles and hybrid electric vehicles charging stations are increasing day by day, sir. In charging, there is three types are there: the domestic charging and fast charging outside, and the third one is replacing the batteries. Actually, in our house, suppose if the cylinder is run out, then we are changing the cylinder with some other one. Okay, what we are doing, we are keeping a spare cylinder and we are operating with the spare cylinder, and we are again ordering the another gas cylinder. So in that way, similarly, the batteries also can be replaced like that. But actually, suppose uh, the number of battery electric vehicles are increased, the type of bunks are also comes into picture. In the bunk, you can easily replace the battery. This question is asked by Dr. Suresh Garu. Suresh Garu, we can do work on that also, sir. Easily replacing the battery. How actually the battery weight is too high. In the Tesla model cars, the battery is not a single battery. It consists of thousands of cells. Thousands of cells which are embedded in the footboard. And those batteries cannot be replaced. Actually, replacing that battery is a very difficult task. But in the Indian models are equipped with some a single module of battery. That battery can be replaced. Suppose if we design a system to replace the battery at the bunks easily, and a machine which is used to pull the battery and to keep the battery to fit the battery inside the car. If we design such type of system, we can patent it and that design can give a better that definitely that will be useful for the electric vehicle industry, sir. That is also a better research area.
Sir, thank you, sir. Thank you very much. Sir, I have one more doubt, sir.
Sir,
So, present we have faced so many challenges in EVs, sir. I think charging station is not only the, challenging task. There are some other issues, sir, like that battery charging, what you told. See, sir, in order to fully develop the EVs or HEVs on road in AP, sir, what is the possible time to implement the fully EVs or HEVs in on road?
yes, sir. We need to observe the scenarios. Actually, at the time of lockdown, when the lockdown came into existence in the year of 2020, at that time, the electric vehicles which are available in the market are very few companies are marketing electric vehicles. That is Morris Garage ZX EV. That is one of the vehicle which came into India at that time, 2020. Okay, that vehicle is giving a range of 250 kilometers, and that vehicle can go from Hyderabad to Bangalore. Okay, after that, nowadays a lot of electric vehicles are coming onto the road. And they are the Tata Nexon EV, Tata Tigor EV, Tata Tiago. But we never seen this much number of models on the road 3 years back. But all these vehicles are came on road in a span of just 3 to 4 years, sir. So you can see the miracles in the coming couple of years. That maybe 2 or 3 years. I think, I hope, sir. I hope. So in 2 or 3 or 4 years, definitely, and actually there is no alternative. Actually, day by day, the petrol and diesel fuels are for the fossil fuels are depleting. So to meet the demand of the fuel needs, we must develop such type of systems. Suppose if you are doing research in that direction, definitely your research will be much valuable, sir.
Okay, sir. Thank you, sir. Thank you very much.
Okay, sir. Thank you very much. It is the time is 9. Srinivas Reddy garu, thank you for and, the opportunity given by you and the principals are Dr. Jayanand garu. Thank you for your concern and thank you for giving this opportunity to address the participants. Thank you, participants and my dear students.
Yeah, thank you very much, sir. So we thank you for taking us through the
Thank you, sir.
detailed. Yeah, please. Yeah, okay. So for giving exhaustive exposure to the various architectures of hybrid electric vehicles, and also for inspiring the participants by showing how a simple innovation can lead to okay. a simple innovation can lead to a wonderful vehicle that we can use for many special purposes. So once again, so I extend thanks to the resource person, Dr. V. Subrahmanyam. And this is for today. So again, we will meet for session 8 and 9. So thank you, sir.
Good. Thank you, sir.
So, good night, all the participants. So meet you tomorrow.